Okay, let's take a look at the single three-dot problem in Chapter 6. This is number 59. It is basically a children's toy, sort of. You have a rod. Attached to the rod you have two strings. Attached to those two strings you have a ball. The ball has some mass, which is interesting in the problem, but we're not going to get that far in talking about it now. And so basically you have a situation where the ball is being swung around in a circle. Swung around in a circle, circle being the key word here, is going to tell us something going on centripetal force-wise. Now they ask for a couple different things. They tell you the tension in the upper string, and then ask for the tension in the lower string, the magnitude of the net force on the ball, the speed of the ball, and the direction of F net. You should already be able to answer D, the direction of F net. You've got to know that one already. The other one's going to take a little bit of doing. So let's consider for a second what forces are acting on our ball. So here is our ball of mass m, and we're going to free body diagram this thing up. So we've got gravity, as we always do. We have a tension from the upper rope. We have a tension from the lower rope. And those are the only things in contact with the ball. Important thing to note, no centripetal force on here. That is not a force that goes on a free body diagram. The net force to undergo uniform circular motion must be the centripetal force, but that is not a physical force on its own. Now, if we look at this, we've got a couple things going on. We know that in the y direction, we've got the y component of the upper tension, we've got the y component of the lower tension, and we've got Fg. And somehow, even though I've drawn this in a way that clearly doesn't actually work, these all have to be equal. Yes? Because it's spinning around in a circle. It's not spinning up, not spinning down. So there must be no acceleration in the y direction. Now, in the x direction, all that we've got are the x components of these two tensions. And we know that this is the claim that this has to be equal to the centripetal force in magnitude. Alright? So with that setup, that should hopefully get you a bit of the way through it. Now, they do give you some lengths. They give you, this is set up as a triangle. Specifically, it's a particular type of triangle. I challenge you to figure that out. Shouldn't be too challenging, though. And that'll help you get angles to get components out. But that is kind of the general setup. Hope it helps. Have fun.